Okay, I am audible. सबको सुनाई दे रहा है मेरा बात?
Yes, sir.
Okay, so we will wait for 2 minutes so that the rest of the students could join, and after 2 minutes we will start the class. Okay, so don't leave the class, wait for 2 minutes, and then after 2 minutes we will start the class. Hello. So we have waited for a long time, and we are not able again waiting for others to join. We have already waited for 7 minutes or some, so that others could join, and those who have joined, we will start the class with them. May I request Orgo sir to please take the attendance of the students in some, you take the screenshot as well as the, you can take the attendance of the name of the students who are present here, or you can ask Muskan, the seer of the lateral, and who is there, our electrical main, electrical departments here, who are there? Muskan is for the lateral and another is,
Rahul.
yes, Rahul is present here. Is Rahul present in the class?
No, sir.
Okay, so Aman, please, take the attendance of your students, and we have the screenshot, so don't do proxy or like that thing. And I am asking also Muskan to give the attendance of the students, and he will send it to Orgo sir, hard copy in the WhatsApp after the confirmation of the class. And Orgo sir, please take the screenshot of the students who are present in the class, so that we can we can tally with the students, with the CR, that they are giving the attendance right or not. Okay. Is it okay, Orgo sir? Orgo sir, are you there? Your sound is not audible, sir. I think there is a network issue with Orgo sir. Let us start our classes, and he will join with he will join within us. So today we will start the class with some theoretical lectures, and then we will go to the practical one. Due to the virtual session of the class, so there is no hardware classes. You cannot get the hardware. So we will go to the virtual platform to do via our digital electronics lab. Already one lab has been conducted by Orgo sir. And in that lab, we have discussed about the basic of gates and all the things. Today we will start the practical, but before that we will do some theoretical part, and after that theoretical part we will go for the lab sessions. We are doing the Zoom session for the lab. That's why I request everybody that it is a 40-minute session. Each session will be of 40 minutes, but this lab is for 2 hours. So I will request everybody, after the disconnection of the classes, please join within the using the same link, but after 5 minutes, because we have to reconnect the class. So I request everybody to join the class within 5 minutes after the disconnection of the class. Within the same link, you will use the same link for that, and please do that. I will not repeat it. So whenever you are disconnected, whenever the class is disconnected, you will have to reconnect it up to 5 p.m. by using the same link, but after 5 minutes. You have to wait 5 minutes. And we are getting we have been constant watching the attendance of the students. So those students will not come in the second or third session of this lab class. So we will not give them attendance throughout the class. So if you want to get the throughout attendance, then you have to be present in every sessions of this class. So any doubt or anything that you are going to ask? Okay, so no doubt, I think, to the students. So let us start the class without further delay. We will start with some theoretical things that we have continued in the last session. and we will start with some theoretical session today, and then we will do some practical session. So I am sharing you the sharing this whiteboard of this. So I think everybody can watch the whiteboard. Is it okay? Everybody can watch it.
Yes, sir.
So last day we are talking about digital electronics classes, and we are talking about that we want to see the gray code and etc. We are doing that classes, okay? The gray code class, the gray code conversion and all that techniques. So we will start today with that thing. So what we are doing about the gray code section, we are converting some binaries to gray code and to gray to binary. Last day we have talked about gray to binary. Today we are going to see binary to gray code conversion. So whenever we talk about binary to gray code conversion, we talk about how to do the conversion. So let us take the example and let us give the example to conduct this problem. So let me start with the example that is binary to gray. Just a minute. What are the steps to do that? The steps are first, we know the steps. Again, I am writing the steps. Just a minute. Step one is to record the MSB as it is, to record the MSB as it is. Just a minute. Something has came in the WhatsApp. Next is add the MSB to the next bit. And record the sum, but neglect the carry. After that, step 3, we will repeat the process. So as for example, if I take an example of that, let us take an example of that. Like we are converting here example 1. Convert 1011 to gray code. So how do we do this? The solution, if I do the solution, 1011 is my bit. So this is the MSB and this is the LSB. So what I will do, I will add first, I will take the MSB as it is. So let us take the MSB as it is. I am taking the MSB as it is. So MSB turned into as it is. Now what we will do? Add the MSB to the next bit. That means we have to add the MSB with the next bit. So if I add the MSB to the next bit, what is it is looking like? So this will be added here. So we will add here 0 with, what is the MSB? 1. So what will be the answer? 0 plus 1?
1.
1. So I will take here 1. Next, I will do the same. Record the sum and neglect the carry. So there is no carry. So there is no question of neglecting. So I will record the sum. So next I will repeat it. So again I am, what I am doing, this 0 will be added with the next bit plus, so here it is 0 and we will get the value again 1 plus 0 is equal to 1, and then again I will do it repeatedly. This means that 1 will be going to that one. So I will write here, this one will be moved here and that is added with 1. So what is the answer? 1 plus 1 equals to 0. But there is a carry, but we will have to neglect the carry. So I'm not taking the carry. So this is the answer. So this is our answer. So this is your answer. That means binary is this and the gray code is this. That means if I write, this is a binary number and this is a gray code. Anybody, any confusion? Is there any confusion to anybody?
No, sir.
No, sir.
No, sir.
No, sir.
Okay. We can do this operation, this neglecting the carry and this adding the MS bit to the next bit by using XOR operation also. By using XOR operation also. If you use XOR operation, we can do it same. XOR operation is nothing but XOR is also called. Do you know what that's the XOR called? XOR is also named as odd one detector. What? Odd one detector. XOR is also called as odd one detector, or it is used as odd one detection. Odd one detection. Do you know what is the meaning of this? If I go for the, most of the students knows about the XOR gate, but just I am doing it again. If I go to the truth table of XOR gate, if I go to the truth table of XOR gate, A and B are the two inputs, and Y is the XOR. And why, how can we write XOR gate? We can write XOR gate as A, B bar plus of A bar B. Everybody knows this operation? A, B
Yes, sir.
bar plus A bar B. XOR can be written as A, B bar or A bar B. So that is also called odd one detection. So if I write 0, 0, that means how many possibility combination will be there? There were possible combinations for what? For 2 bits, how many possible combinations will be there? 4 possible combinations: 0, 0, 0, 1, 1, 0, and 1, 1. Is it all right?
Yes, sir.
Okay. So I told you odd one detection. How odd one is there? If there is an odd one in the input possible combinations, then we will get in the answer high. That means or XOR gate will give always high input if there is an odd one in the input combination. So let us see 0, 0. There is no 1. So I will get the input low. Next is 0, 1. So here it is an odd one combination. So I will get the output high. Here it is 1, 0. So again, there is an odd one combination in the input. Only one is odd number. So only one odd there in the input. So that will be high. And this is 1, 1. So there is an even one combination in the input. So it will be 0. So that's why it is also called odd one detection. Because wherever there is an odd one in the input, wherever there is an odd one in the input, you can see there the combination will be 1. Output, or the output will be high when there is an odd one in the input. In the input, when the combination has an odd one, then the output will be high. That's why XOR gate is also called as odd one detector, or we can detect odd one by using XOR gate. लास्ट जो टॉपिक में मैंने बोला आप लोगों को समझ में आया क्यों एक्सओर को मैं ऑड वन डिटेक्शन के काम पे लगाता हूं? आप लोग क्लियर हो?
Yes, sir.
अच्छा, सभी क्लियर हो जितने भी आदमी है?
Yes, sir.
Yes, sir.
ओके, तो इसको मैं अप्लाई करके यहाँ पर बाइनरी से ग्रे कोड कन्वर्ट करूंगा. मतलब हम लोग सिर्फ ऐसे एडिशन ना करेंगे, हम लोग एक्सओर ऑपरेशन करने से भी हम लोग अपना बाइनरी से ग्रे कोड कर सकते हैं. वी कैन फाइंड आउट ग्रे कोड फ्रॉम बाइनरी और बाइनरी ग्रे कोड टू बाइनरी by using XOR gate. XOR gate also makes us to also help us to determine the gray code of a binary bit. Okay? तो कैसे करते हैं? एग्जांपल लेते हैं. हम लोग एक एग्जांपल ले लेते हैं जहां पर हम XOR गेट को यूज करेंगे. एग्जाम्पल 2 ले लेते हैं। तो एक बात श्योर है, अगर हम लोग एक जनरल एक्सप्रेशन की बात करते हैं, जनरल एक्सप्रेशन, तो हम लोग बोलते हैं जनरल एक्सप्रेशन में कि बाइनरी टू ग्रे और ग्रे टू बाइनरी दोनों में ही हम लोग क्या करेंगे, एमएसबी रिमेन्स द सेम। एमएसबी को हम टच नहीं करेंगे, एमएसबी रिमेन्स द सेम। और अगर हम इसको बीट के हिसाब से देखें, बीट के हिसाब से देखें, जैसे कि ये ग्रे कोड का बीट, तो इसको हम लोग ग्रे कोड से रिप्रेजेंट कर रहे हैं, जी ऑफ 3, जी ऑफ 2, जी ऑफ 1 और जी ऑफ 0 से रिप्रेजेंट करते हैं। और इस वाले को हम लोग रिप्रेजेंट करते हैं बाइनरी, सो बी ऑफ 3, बी ऑफ 2, बी ऑफ 1 और बी ऑफ 0 से रिप्रेजेंट करते हैं। तो हम लोग थ्रू अवर जनरल ट्रिविया और जनरल एक्सप्रेशन हम लोग बोलते हैं कि G3 इक्वल्स टू B3, ओके, G2 is equals to what? G2 is equals to what? क्या बोल सकते हैं? G2 is
B2.
no, G2 equals to B2 XOR B3. B2 XOR B3. B2 XOR B3, देखिए B2 और B3 की अगर XOR होता है, मतलब 0 और 1 में अगर XOR होता है, 0 और 1 में XOR होता है, तो आउटपुट 1 होता है। वही मेरा G2 पे रिफ्लेक्ट हुआ है, आप लोग देख सकते हैं G2 पे वही रिफ्लेक्ट हुआ है। दैट इज नथिंग बट B2 और B3 के अंदर हम लोग XOR ऑपरेशन किए। अंडरस्टैंड?
यस सर।
तो
Yes, sir.
हमको मुस्कान बताओ, अगर हम जनरल में लिख सके, व्हाट विल बी द कॉम्बिनेशन ऑफ G1? मुस्कान बताओ।
B1 plus
क्लास नहीं, XOR,
oh sorry sir XOR.
XOR B2। हाँ,
Yes, sir.
G1 होगा अपना, आप देखिए G1 होगा B1 और B2 की बीच में XOR ऑपरेशन। यहाँ पर क्या है, B1 में है आपका 1 और B2 में है 0, तो 1 0 1 वही आ रहा है G1 में। और लास्ट वन क्या आएगा, G0, रितिका कुमारी बताइए जरा, G0 क्या होगा?
Sir, B0 plus B0 XOR B1.
B0 XOR B1। अमन, क्या ये सही बोला? अमन जी, आप है कि नहीं?
यस सर।
इज इट ट्रू? G0 is equal to B0 XOR B1. सुनाई नहीं दे रहा है? हेलो,
Yes, sir. Yes, sir.
तो एक और एग्जांपल मैं देता हूं आप लोगों को, थोड़ा करके बताइए। एग्जांपल 2, 3। एग्जाम्पल 2 में मैंने आपको दिया है 1 1 1 0। तो इसको आप XOR ऑपरेशन से फ्रॉम बाइनरी टू ग्रे कोड में कन्वर्ट कीजिए। तो पहले मैं क्वेश्चन करता हूं चिंटू कुमार से। चिंटू कुमार है? चिंटू जी, तो चिंटू जी नहीं है। ऑर्गो सर, आर यू देयर? ऑर्गो सर?
Yes, sir.
Orgo sir, please mention that Chintu Kumar is present in the class, but he is not communicating, so he will be absent. Okay. Okay. So next, I am asking Preeti Kumari. So Preeti, can you tell me?
Yes, sir. 1
Okay, 1
0 1.
कैसे किया आपने, थोड़ा बताएंगे? 1 तो डायरेक्ट वो आ जाता है क्योंकि वो MSB है, ठीक है। फिर XOR गेट करना है मुझे, तो किसके साथ किसको इसका XOR गेट करो बताओ। बोलो प्रीति कुमारी, तुमको बात कर रहा हूँ।
Yes, sir.
किसके साथ किसको XOR गेट करो?
B2 को G2 से।
यहाँ पर बताओ, B2 G2 मालूम नहीं, यहाँ पर किसके साथ किसका XOR गेट करो? यही प्रॉब्लम है तुम लोगों को कि तुम लोग पढ़ाई नहीं करते। यहाँ पर 1 के साथ 1 XOR गेट होगा तो वो बन जाएगा 0, क्योंकि मैंने बोला MSB के साथ नेक्स्ट बिट का XOR गेट होगा। तो फिर नेक्स्ट के लिए रॉकी हंसदा, आप बोलिए नेक्स्ट में किसके साथ किसका XOR गेट होगा? रॉकी, so this much students are not here in the class. Sweta Prakash,
Yes, sir.
which one and which one will be XOR get now?
सर 1 ऐड हो जाएगा तो 1 + 1 = 0 हो जाएगा।
1 + 1 नहीं, 1 XOR 1
हाँ, XOR 1.
equals to 0.
Yes.
Okay. Suman Malik?
यस सर। सर 1 ये XOR होगा 1 XOR 0 1।
1 XOR 0, 1. So this is the answer. This is the binary number. And this is the gray code number. So this is binary. And this is gray. Same thing we can do when we will convert from gray to binary. So next class, that means next session, this session is going to be over. So in next session, we will firstly do the gray to binary conversion with XOR gate, and then we will go for the practical sessions. So after the end of the class, please wait for 5 minutes and again join using the same link. Okay.
Okay, sir.
After the end of this session, please wait for 5 minutes and again join using the same link, because just 1 minute and 18 seconds are left for this class. So same thing we will do for the gray to binary, and that will be next in the next class.
Sir,
Ah,
please show the first page now.
this is the first page.